Thank you, Prashant and Arvind. Hello, everyone. My name is Arkady Shapiro, and I'm Principal Technical Marketing Engineer at Big Switch Networks. In this demonstration, I will provide an overview of VMware Integrated OpenStack deployment running on top of vSphere and NSX with Big Cloud Fabric. Along with that, we'll observe the benefits of physical fabric automation and advanced visibility into virtual environment that the solution provides. Here's the setup we'll be using today. We have a Big Cloud Fabric with two dual-leaf racks, two spines, and a pair of SDN controllers. Several ESXi hosts connect to each rack. We deploy two vCenters, one for classical vSphere networking corresponding to Virtual Pod 1, and another one for VMware Integrated OpenStack and NSX corresponding to Virtual Pod 2. Big Cloud Fabric is connecting to both vCenters. OpenStack and NSX Manager communicated with vCenter 2 only. As Prashant alluded to earlier, this provides a unique value to a customer who may have an existing vSphere deployment and wants to deploy VMware Integrated OpenStack without disrupting existing environment and without building a whole separate physical fabric. Here's the deployment workflow for the solution. Once Big Cloud Fabric, vCenter, NSX, and VIO are set up, we enable VCF integration with vSphere by registering VCF controller with vCenter. On NSX, we do host preparation, which creates VXLAN tunnel endpoints and NSX transport network. This network is used for all NSX VXLAN traffic going across physical fabric between VTAPs. Then we deploy VMware Integrated OpenStack on vCenter. OpenStack Nova uses vCenter driver to leverage vCenter for VM scheduling and management. Similarly, OpenStack Neutron uses NSX driver for all networking needs. Lastly, we create an external network on VIO to enable external connectivity to OpenStack tenants. The demo will highlight specific operational benefits that can only be realized when deploying and managing our joint solution. We'll talk about automatic ESXi host attachment, NSX transport network creation, VTAP to VTAP visibility, and VCF analytics for NSX. So let's first review the setup and talk about deployment benefits. Let's log into VCF Fabric and see the physical SDN Fabric setup I mentioned earlier. We can see two controllers, several racks, and two spines. Clicking on any switch can show fabric links along with utilization. Let's go to Integration tab to enable VMware vCenter integration with VCF. We have already enabled it by providing several parameters such as username, password, and tenant corresponding to virtual pod and other information. Let's look at vCenter web interface. We have two vCenters as mentioned earlier, one corresponding to Virtual Pod 1 with classical vSphere setup, and one corresponding to Virtual Pod 2 with vSphere, NSX, and VIO. In vCenter 2, we have a compute cluster for VIO workloads, edge cluster for NSX edge routers, and management cluster for VIO and NSX infrastructure components. Now let's look at NSX configuration. As you see, all ESXi hosts and compute and edge clusters have been prepared for NSX networking. In VXLAN section, all hosts have VM kernel interfaces corresponding to VTAP endpoints on each host. On VMware Distributed Switch, NSX host preparation created port group corresponding to NSX transport network. Let's go back to Big Cloud Fabric and look at physical fabric automation. We can see the ESXi host being discovered via LODP and link aggregation groups automatically created, including all uplinks from virtual switch on ESXi. Expanding on individual link aggregation group, we can see how hosts are physically connected to switch ports and corresponding ESXi VMNIC info. It is important to note that without a zero-touch physical network solution that Big Cloud Fabric provides to complement the virtual network solution from VMware, this task would be very time-consuming and error-prone. Let's look at the second part of fabric automation. As you see in tenant configuration, Big Cloud Fabric auto-creates segments for all VMware virtual switch port groups. Here we have NSX transport network and external network. Big Cloud Fabric also auto-provisions and prunes segment membership based on presence of VM or VM kernel interfaces. In endpoints under the segment, we can see VM kernel interfaces that correspond to VTAPs. Big Cloud Fabric provides valuable information about additional endpoints that are behind VTAP and therefore do not directly connect to the fabric. Similar information can be seen in vCenter Integration tab under specific vCenter. except here it is focused on just the virtual machine endpoints under that specific vCenter. We have looked at host, segment, and endpoint information from perspective of vCenter and BigCloud Fabric. If we go back to vCenter and go to the BigCloud Fabric vCenter plugin view, you can see much of this information merged together in a single pane of glass. For example, looking at virtual distributed switch on specific host, we can see corresponding port groups, including VM kernel and those behind the VTAP, as well as physical uplinks. In segment view for NSX Transport Network, we can see that Fabric membership in NSX Transport Network was provisioned for these hosts. Now, let's take a look at OpenStack setup and tenant multi-tier application deployment. We have deployed OpenStack in vCenter management cluster with controllers, load balancers, and other infrastructure virtual machines. If we log into OpenStack Horizon Dashboard using a pre-created project credentials, we can see that we have deployed a tenant, networks, and routers. We have added 2 virtual machines in each network. Going back to vCenter, we can see NSX deployed logical switches corresponding to each network. Each one is mapped to a specific VXLAN virtual network identifier, or VNI. Let's look at the virtual machines that are deployed. We can see virtual machines app1 and app2 from network app, and virtual machines web1 and web2 from network web. From BigCloud Fabric, there is no configuration change for these virtual machines, since the network acts as a physical underlay for NSX overlay. Let's log in to virtual machine app1 and ping virtual machine app2 in the same segment. Now let's ping virtual machine web2 in another segment. We have now deployed application using OpenStack with vCenter, NSX, and BigCloud Fabric handling workload traffic. Finally, let's look at how BigCloud Fabric brings extra visibility to VMware Integrated OpenStack and NSX deployment with test path and analytics. Starting with test path, we can trace a path between VTAPs. Earlier, we noted VM kernel endpoints corresponding to VTAPs on ESXi servers. We can pick endpoint corresponding to VTAP on server 9 as a source and VTAP on server 8 as a destination. Simulate option provides a controller view of whether communication should occur. A test mode provides an interface level details and actual path that was taken by VTAP to VTAP traffic across the BigCloud Fabric. Now let's look at BigCloud Fabric Analytics, which is there to give details on Fabric, vCenter, and NSX events. First, let's look at all VMware events, where we can see information on all vCenters, hypervisors, and virtual machines. Here we also have ability to drill down on any one of them for more specific event information. Next, we'll focus on NSX Dashboard, where we can see information on VXLAN virtual networks and associated virtual machines. For each VM, we can view events which, along with the type of event, will show useful information like logical switch name, VXLAN virtual network identifier corresponding to NSX logical switch, and virtual machine name. In summary, BigCloud Fabric leverages vCenter integration to provide physical fabric automation and visibility for VIO deployment, which uses vCenter and NSX for VM provisioning and networking respectively. Like Arvind and Prashant mentioned, the solution is very simple and one can get up and running with their private cloud in no time. This concludes the demonstration, and I'll turn this back to you, Bala.